Welcome to the lesson Kinetic and Potential Energy, where you'll learn about the relationship between these two forms of energy. The vocabulary words for this lesson are kinetic energy, potential energy, mechanical energy, and law of conservation of energy. Energy is the ability to cause change. Two important fun types of energy are kinetic and potential energy. Without them, there'd be no sports or fun things like skateboarding or skydiving. Click on the pictures to learn more about them. Potential energy is the stored energy of an object. One of the most common forms of potential energy is gravitational potential energy, or the energy an object has because of its position. The higher an object is, the more gravitational potential energy it has. For example, a skateboarder at the top of the halfpipe has lots of gravitational potential energy, while a skateboarder at the bottom of the pipe has none. Kinetic energy is the energy of motion. An object in motion has kinetic energy. The amount of kinetic energy depends upon its mass and its speed. The faster an object is moving, the more kinetic energy it has. A race car speeding down a straight has much more kinetic energy than a car coming to a stop at the end of the race. Kinetic energy also depends on the mass of the moving object. The greater the mass, the greater the energy. For example, a heavy delivery truck moving slowly down the street has more kinetic energy than a compact car moving beside it at the same speed. The world is full of movement, full of objects rising and falling, coming to a stop, and then moving again. Potential and kinetic energy are often found together. When considering objects in motion around you, the combination of kinetic and potential energy is known as mechanical energy. Since mechanical energy is equal to potential energy plus kinetic energy, an object's mechanical energy never changes. Mechanical energy isn't gained or lost. It simply changes between kinetic and potential energy. Click on the image of the car to learn why this is so. At the top of the hill, this car isn't moving. Its position gives it potential energy. On the graph, you see potential energy, but no kinetic energy. So all of the mechanical energy comes from potential energy. Click the next picture. The car has started making its way down the hill. Now there is some kinetic energy because the car is moving. However, you can see that there is still potential energy because the car is still near the top of the hill. But as the graph shows, the mechanical energy has stayed the same. Click on the next picture. The car is about midway down the hill. It has half of the potential energy that it had at the start. All of that potential energy has been transformed into kinetic energy. So the car has equal amounts of kinetic and potential energy. Mechanical energy has not changed. Can you match the types of energy to the correct position? Drag each label to the spot that best describes the form of energy pictured at each point. Right. Where the ball is moving, it has kinetic energy. Where it is, but still could fall, it has potential energy. Energy is never lost or gained, it just changes between different forms. This is known as the law of conservation of energy. Play the video to see the law of conservation of energy in action. At the top of the half pipe, this skateboarder only has potential energy. As the skater rolls down the pipe, the potential energy changes to kinetic energy. At the bottom of the pipe, the skater is moving pretty fast. All of his potential energy has changed to kinetic energy. The kinetic energy carries him up the side of the half pipe. As he moves upwards, he starts to slow down. His kinetic energy is changing back to potential energy. When the skater gets to the top of the pipe, all his energy is potential again, and so he rolls back down the pipe again. So where does potential energy come from? In many cases, it's from gravity, the force that Earth applies on objects. In other words, it's the pull that holds us to the ground. The amount of potential energy that comes from gravity depends upon two things: the mass of that thing and its distance from the ground. Look at the divers. Diver 1 is higher than diver 2. If the two men had the same mass, then diver 1 would have more gravitational potential energy. What if they were the same height, but diver 2 had more mass? Then he would have more gravitational potential energy. Drag each picture to the correct section. Right. If an object is about to move, it has potential energy only. If an object started moving but could move faster or more, it has both kinetic and potential energy. Once an object is moving its fastest, it only has kinetic energy. True or false? The mechanical energy of a roller coaster is greater when it rolls down the hill than when it rolls up the hill. That's right. Mechanical energy never changes, so it wouldn't be greater or less at any given time. But energy does get lost due to friction between the cars of the roller coaster and the track. Giving the cars the most mechanical energy at the possible start will ensure that they have enough to finish at the end. Throughout the ride, mechanical energy keeps switching between potential and kinetic energy. But the designer of the roller coaster knows that he has to design it to make sure that there's enough energy to carry it through. Click the picture that shows an object whose energy is mostly potential. Great job! Remember that potential energy is the energy of position and that it is energy that is not moving. Only one image shows potential energy without much motion. So the skydiver has mostly potential energy and has little or no kinetic energy. Look at the picture. Write what would happen to the kinetic and potential energy of the soccer ball as it rolls down the ramp. When the soccer ball is at the top of the ramp, it has mostly potential energy. As it begins to roll down the ramp, that potential energy converts to kinetic energy. At the bottom of the ramp, it has mostly kinetic energy. You've learned a lot about potential and kinetic energy, but before we finish, let's take a look at the main points that you covered. There are two types of energy: potential or stored energy, and kinetic, the energy of motion. Mechanical energy is equal to potential plus kinetic energy. The mechanical energy of an object is not lost. This is the law of conservation of energy, a fundamental law in science. Now that you've finished the lesson, click the menu button to exit, or if you wish, go back and review any part of the lesson again.